Welcome to this presentation, and thank you for joining us. All right. So in this video, we want to look at integration by parts, and I must mention that this video is useful for university students. Okay, those university students doing mathematics can watch this video. It can really help them. Now, this integration by parts will be done by what we call the tabular method. We use a table in short, all right? You remember that the ordinary way of integrating by parts, we normally say, um, suppose we have the integral of u dv, all right? Then we'll have u dv that is equal to uv minus the integral of v du, all right? This is what has been used. It's the ordinary one, okay? Or the method that most people know. But in this case, we are going to use a table, all right? Okay, we are going to use a table, okay? So let's have a question. Question one. Let's see what we have. Integrate. Or let's say find the integral of x squared e to the power x dx. This is an indefinite integral. All right. How do we go about it? Okay. So let's have our solution. So what we are going to do is we'll pick what we can differentiate and what we can integrate, all right, easily from these two. So you can see that we can easily differentiate x squared, then the rest will be integrated. Okay. So what is the derivative of x squared? We have 2x, all right? So we'll keep on differentiating not until we get 0. What is the derivative of 2x? We have 2. Then what is the derivative of 2? Since it's a constant, we have 0. Then here we integrate. What's the integral of x? E to the power x is 2 e to the power x equal here to e to the power x, e to the power x. Now, we are going to get the diagonal product, all right? So we'll get the diagonal products like this, like that. But we are going to start with plus, minus, and plus, okay? What does it mean? So the first one will be positive x squared times e to the x, e to the x. Then we have minus 2x e to the x. Then plus 2 times e to the x, so we have 2 e to the x plus the arbitrary constant. All right? So if you want, you can factor out the e to the x. Okay. You can factor out the e to the x. So you have e to the x, open bracket, x squared minus 2x plus 2 plus the arbitrary constant. This is your solution. All right? Next, maybe I can pick another question. Maybe question 2. we have this one. We need to find the integral of x squared minus 3x e to the x with respect to what? X. So with respect to x. Okay, good. So again, we are going to get the derivative and the antiderivative for the integral. All right, so the function that we can easily differentiate here is x squared minus 3x. Then we'll keep our integral as this one. We'll integrate that. So the derivative of x squared minus 3x, it is 2x minus 3. Okay. Here we'll say e to the x. Then when we differentiate this, we are going to get a 2, right? Then here we have e to the x. Then when you differentiate this, we'll get 0. Here we have e to the x. Now, we are supposed to get the diagonal products. The diagonal products. So this, but it will be plus. Then with this, it will be minus. It will alternate, starting with plus. Then plus. Okay. So what do we have? We have x squared minus 3x. You multiply this by e to the x minus 2x minus 3 times e to the x plus 2e to the x 2e to the x plus the arbitrary constant, all right? And upon factorizing, what do we get? If we factor out e to the x, we'll have x squared minus 3x, all right? Minus 2x plus 3 plus 2, then plus c, right? So eventually we'll have e to the x is equal to x squared minus 5x plus 5 plus the arbitrary constant. This is our solution, right? Okay, and that's where we end for this video. Please subscribe to our channel and share with your friends. Okay, till next time. Bye-bye. God bless.